Hi, Philip. Can you hear us?
Yes, cool. Okay, right. That's wasted 3 minutes of my slot, so I should better start. Um, cool. Hello, everyone. In this talk, I'm going to cover some of the changes we've been making to the threading model in GNOME software over the last couple of cycles. Work on this has been done by Endless and by Red Hat. And the aim is both in the talk to provide a bit of a progress update for those who are interested and to provide some more general ideas about what works and what doesn't work so well when you're using threads in a program in C using sort of GNOME technologies. And then I'll briefly cover some things and I'll put it on the record. But right from the beginning, the architecture has been sort of plugin based. And I believe the idea with that was that you could have one or more plugins per distribution. So the UI of GNOME software could be shared between distros, but it could still function with different package managers, so RPM or Deb or a plethora of others. So because of this, a lot of the original API design was done with those traditional package managers in mind, because at the time, Upstream is now quite a fundamental part of GNOME software. It's an excellent GNOME software now. But at the time when GNOME software was started, the decision to standardize on Upstream a couple of cycles ago. So in this old architecture, you've got each job, such as, let's see if annotations work, these things here, these big boxes. So jobs are like refreshing metadata. So plugins are run in a fixed order, which is defined when GNOME software starts up. This allows them to modify the results returned by earlier plugins. So, for example, some plugins, such as the Flatpak plugin, will add apps to a list of results for the job, and then later in the job, the icons plugin might go through that list of results and download an icon from the internet for each app in the list, and then modify the results in place and carry it on to the next program, the next plugin. So this isn't shown in the diagram for kind of space-saving reasons, but it is a part of the architecture. So each plugin function does its work synchronously. So like the work being done is represented as one of these boxes going through time. So some of them are longer, some of them are shorter, and that corresponds to sort of more or less work being done. And they're synchronous, so they don't yield control of the thread they're in until they're finished with the work they're done, and finishing is represented by these arrows here. When all of the plugin functions have returned for a particular job, the main thread marks the job as complete and it returns results to the caller. So that could be like finishing off installing an app, or it could be returning the list of applications for a search or that kind of thing. So this job number 2 here is only complete once this load of work for this plugin has finished. So in this diagram, we've got 2 jobs, so one here, and 5 thread pool threads. And that's kind of quite a cut down example of what GNOME software actually does. I've not shown the sequential ordering of plugins for reasons of space, but I have shown the serialization of jobs, which happens. So that's represented by these sort of outline boxes here, which is where the code running in this little piece of work here can't start until this one has finished, because it's waiting on a shared resource, like they both are operating on the Flatpak database or something like that. So this means that there's a lot of locking going on inside the plugins in GNOME software, and it serializes everything and delays subsequent jobs until the earlier ones are finished. So this raises a number of issues. As the complexity of GNOME software and the number of plugins in it grew, it kind of became apparent that the architecture did not scale well enough. The most immediate problem that I kind of alluded to in the previous diagram was that the number of threads in the thread pool is limited. And so it's possible when you've requested maybe like 20 of them to hit a deadlock if the limit is reached, and then all of those pending threads are waiting on another operation which they can't start because there's no more threads left in the thread pool. This can happen more often than you'd think when you're using OS3 and Flatpak, because they both can request thread pool threads to do network operations. So this is the cause of quite a lot of sort of hangs or deadlocks in GNOME software, and it's not an easy issue to fix. I mean, one solution would be to just increase the limit on the number of threads in the thread pool, but kind of where do you stop with that? Every time you increase it, it's possible to hit the deadlock again after a few more pending operations, and there's no kind of guarantee that you're ever going to choose a limit that's high enough. So the long-term fix for that is to decouple the number of threads from the number of pending operations or pending jobs. Oops. Another problem with using a lot of threads is that they consume significant resources. So while each thread sort of theoretically shares the full address space with the rest of the process, glibc actually reserves a load of 64 meg of private heap pages for each thread, which is kind of for reasons of performance when you're doing malloc. So rather than on each malloc call sort of making glibc lock some shared heap metadata and do your allocation and return it to your thread, it actually just gives you a new heap for each thread, which you get your allocations out of without any locking, which is great for performance and not something that we should really turn off at all, but not so good for memory usage when you're using 10 or 20 threads, because that equals like a couple of gig of extra memory usage attributed against your process. So yeah, that, like 10 thread pool threads equals 640 meg of non-shareable memory use, which people complain about. And they're kind of right too, although not much of that memory usage is actually has to be physically backed. So it's kind of more of a problem of perspective than an actual lack of resources on the system. But it's something that would be nice to improve on. The third and fourth problems that we've kind of identified with it relate to how work is scheduled on threads. So as I mentioned with the diagram, we've got locking issues, and then we've got overhead issues. So a lot of the work that GNOME software, so each plugin ends up doing, is quite simple. It doesn't require much CPU time. It's not very I/O intensive. It's actually just kind of pushing lists of applications around to different places, like pushing them around to PackageKit or pushing them around to Flatpak. In particular, several of the plugins just talk to another daemon over dbus, and they don't really do any intensive work themselves at all. So in order to do this, they use gdbus, because that's the dbus binding we've got available. Whenever you make a method call in gdbus, the calling thread puts together a dbus message packet, and then queues it. So let's say the calling thread is this worker here. I've just crossed out that word. Let's do that better. There we go. So the calling thread puts together a dbus message packet, which is this blue box of work here. And then it queues it to a gdbus worker thread, which is provided by glib always. Like that's just how glib implements it. So that's queued over here. And then the gdbus worker thread does a little bit more work and then sends it off to the dbus daemon, which does some stuff, and that goes off to the daemon you're calling, like package kit or the Flatpak system helper or whatever. That does some stuff, comes back, gdbus does a bit more processing of the results, sends the result back to your worker thread, and then eventually it goes back to your main thread where GNOME software has been waiting for a result. So all in all, you've not really got much work happening. Just these 4 little boxes here, 2 of which happen within glib, so you actually don't care about them. So actually the only work that your software is doing is that and that. And all of this time in the middle, it's just sitting there waiting for a result, not doing anything else useful. And it's basically just asleep. So that occupies the thread pool threads in GNOME software for a relatively long time, because inter-process communication takes on the order of 10 or 20 milliseconds. And during that time, the thread isn't doing anything else useful, which is not a particularly efficient use of that thread resource, given that threads are scamped. So just to recap, that's the previous architecture. Some of these big boxes here on the right could be one of those dbus calls, or they could be something more intensive. And now we have the new architecture. So the key change here is that plugins are basically now in charge of their own threading model, rather than being forced to use a thread pool thread for everything they do. So we can see that some of the plugins can work entirely in the main thread. So like this one here. That piece of work was previously done in a new thread pool thread, but now it can be pulled into the main thread and just be executed pretty fast there without using a thread pool at all. Other plugins which need to do more blocking operations, so Flatpak is an example of this due to the way its API is designed, they can explicitly run in their own thread. So now, instead of running all the Flatpak operations in separate thread pool threads, we've got one dedicated thread for Flatpak, and then we've got another one for AppStream, because that needs it at the moment. And there are a few more, but there are a bounded number of threads being used now. This also means that we can set kind of appropriate scheduling priorities for each of the worker threads to make sure that they don't consume disproportionately much CPU time or I/O priority, which is quite nice. So I guess the key thing here is that now the width of this graph here is bounded. We can kind of guarantee we're not going to exhaust the thread pool. The other benefits of the plugins which now operate without a thread, like this one over here that's now happening in the main thread, is that they no longer need to do any locking because they're not operating across multiple thread pool threads. So that means you can get rid of the serialization, you can do more work in parallel, or well, not in parallel if it's in the main thread. You can do more different jobs in parallel, and you can improve the parallelization if you make your locking more fine-grained. And we've done that a bit, and there's a bit more scope for doing that in future. The locking and the serialization are still kind of required for plugins like AppStream and Flatpak, where you're accessing shared resources provided by those libraries. So like here, there's still some serialization going on whilst this second piece of work waits for this first one to complete within the Flatpak plugin, and that's unavoidable. So using fewer threads for the plugins also obviously means a reduction in the non-shared memory footprint of GNOME software. So I'm not going to say it's going to be as much as 640 meg, but because we're still using quite a number of threads, but at least it's not going to grow unboundedly. There is still more work to do in this area, because there are various other memory reductions we can do due to kind of unrelated changes. And the other big change is the new way for plugins to make dbus calls is to just do them from the main thread. and then wait for the response in the main thread. But whilst you're waiting, you do other work in the main loop, and you're not occupying an entire thread, just sort of sitting there waiting around for a response to come. So that's a more efficient use of the resources we have. This also makes it more easy for a plugin to have multiple dbus calls in flight at once. So previously you kind of make one call, wait for the reply, make the next call, wait for the reply. And now we can make all of the calls at once and then wait for all of the replies. And once they've all come back, we can get on with whatever's next. So we've done some improvements in the package kit plugin, which is not shown in this diagram, to that end, to kind of run various, I think it's calls for listing applications when you're kind of working out what apps are installed already or what apps are available. So they're all now done in parallel, which should be a little bit faster. And finally, changing the architecture has allowed us to kind of split plugin jobs up into one class per job rather than one kind of generic GS plugin job class, which is reused for everything. This doesn't allow for any performance improvements, but it does make the code a lot more readable. So there's now a separate class for querying for apps and one for refreshing repo metadata, and it improves type safety and hopefully makes things easier to contribute to in future. It also means that if we want to add more specific or different progress reporting for different jobs, then there's sort of some code to hang it off in the future, which should make it a bit easier to kind of do user visible improvements like that later on. So those are the two architectures, those are the changes. I think I can do questions about them later on if people have any. But for now, I'm going to sort of switch to a different part of the talk, really. It's going to be a little bit more like a general software engineering textbook, but hopefully some ideas. We're kind of thinking about what the trade-offs are when writing threading in C in the GNOME environment. The trade-offs when you're using higher level languages or when you're using other toolkits might be a bit different because they provide different primitives and constructs, and they help you kind of guide you towards different ways of constructing your code. Obviously, using a more modern or a more high level language rather than C is probably the best way to go if you have the choice. But there are various places in GNOME where, sort of due to the rest of the ecosystem being in C, or sort of the momentum of a project already being written in C, it's kind of pragmatic to still write new code in C. And in these cases, you basically have the choice between writing synchronous code, which always runs in a worker thread, or writing asynchronous code, which can run anywhere you want it, really, in the main thread or in a separate thread, depending on what seems best at the time. Writing code synchronously is easy, and it's easy to read and easy to maintain because it's kind of all linear and sequential. But when you're writing asynchronous code, it requires more boilerplates. It's harder to maintain because of the boilerplate, because you've got, rather than one function that's linear, you've got one function and a callback, and maybe a thread helper in the middle. So you've got several functions which are kind of all doing the job of logically one thing. The benefit that this provides, though, is that it defines the yield points in the code, where the code kind of needs to block on I/O or needs to block on some other synchronization point. And so once you've defined those yield points, you could use those in various different ways to yield control or not yield control, depending on whether you're running it in a thread or in the main context, in the main thread, or some other way. It's basically not possible to define those yield points in synchronous code because there is no yield keyword in C, and there's no way of doing it without splitting things up into multiple functions. And that's just one of the limitations of C. So if you do write these things asynchronously and define these yield points, it can be fairly trivial to run them synchronously if you want by writing an async to sync wrapper, which is like 10 lines of code. And for this reason, I think it's this reason, and kind of as a result of doing all this stuff in GNOME software, I think it's pretty much always better to define all your APIs that could ever block as being asynchronous. And even if you make the initial implementation of them be entirely synchronous, you can always rewrite it later to be asynchronous. Or you could just use a high-level language in the first place. So GNOME software didn't do that. And so all of the code written afterwards didn't really have the choice of where it was run, whether it was run in a thread or not in a thread. And that kind of just compounded with all the later development. I think this is basically just a result of the age of GNOME software, because all of these kind of coding patterns came about in the 2 or 3 years after GNOME software was first written. So it's a learning process, really. In the last minute or so, I want to go through how we went about landing these changes. From my point of view, it's kind of worked out fairly well. I mean, others might give you a different perspective because they were the ones having to review it. But yeah, the series of changes to GNOME software is quite large. So we're now up to about 30 merge requests. And one thing that seems to have worked out quite well is to just keep landing fairly small chunks of work fairly often, and to keep the rest of the work quite close to main. So don't ever like write an 80 commit behemoth of a branch and then try and break it up later. Just keep doing it in chunks and keep landing it as fast as you can while keeping everything working. That means that sort of the changes are easier to review. They've had minimal merge conflicts, and all of this code that's landed earlier on has had more testing because it's been in main and been in use. And the bugs which we've found in it, because we've found quite a few, have informed subsequent parts of the development. Kind of the downside to that is that all the old code that you're trying to replace has to hang around for longer, and it gets gnarlier, and you've got like integration points between the old code and the new code, and that all stacks up for a long time until eventually you can dump the old code. So you don't really get the pleasure of getting rid of it all in the first place. I guess the other advantage of landing smaller chunks of code quite often is that it allows the work to be split up with multiple people contributing different parts of it at different times, doing code, doing reviews, swapping around. So on that end, I want to thank Milan and Georges for and everyone else who's been involved in doing the reviews and doing the coding, because it's been pretty collaborative. And that's that. So let's see if there are any questions. Shared notes. So, first question. What tips and tricks do we have, and what tools can I recommend for dealing with debugging asynchronous code in glib? There's not many, really. Unfortunately, there aren't many tools for dealing with this that are in a kind of advanced state. So really, probably the best approach is to keep your asynchronous functions small and compose them together and do unit testing on the smaller ones. Because once you start getting really complicated, big asynchronous functions with state machines inside them, it just becomes very hard to test. But it'd be good if there was more tooling for it. And yeah, if people want to work on that and produce something nice in Builder that can kind of tell you what asynchronous functions are still in flight and which ones have returned and what each thread is doing, that would be fantastic. But yeah, we're maybe a little way off that yet. Next question. Have you observed significant differences in how DNF hammers GNOME software threading versus other packaging systems like apt? Personally, I haven't really observed many differences because I just do my development on one distribution, which is not a great thing to say when you're working on a cross-distribution package manager. But I guess the focus of my work has been on the core architecture at the moment rather than the behavior of individual plugins. I mean, a lot of the differences between different distros are actually abstracted by package-kit, which GNOME software uses. So that's kind of slightly removed from being my problem at the moment. So yeah, that's not a great answer to your question, but sorry, I don't really know the full answer. And number 3, when I submitted the Epiphany plugin for review, this is from Phaedrus, who I suggested making it async to save on memory resources. And in Phaedrus's opinion, this was at significant cost to readability of the code. is there a way that we can have our cake and eat it too, to have readable code which is performant with respect to writing async versus async code? Not really. I think that's, well, you can by writing it not in C. If you write it in a different language, which has, there's some cheering going on in the background here in Germany. If you write it in a different language that has high-level support for asynchronous functions or yields, then you could have your cake and eat it too, and that would be something that would be nice to have in Game software in future, is like support for plugins which aren't written in C. But for the moment, if you're writing it in C, the best you can do is just do the boilerplate in a fairly standard way, so that anyone who's reading it, who's read more of that code before, can kind of filter it out in their head. So one trick I like to do is to make the worker function inside an async call be declared after the start function, which I can try and put some examples together about afterwards, because explaining that in a talk is not going to work very well. Maybe I'll do a blog post about it. That's probably the best way to answer. Yeah, I don't think I can give any more tips without writing code out. And I think that's it for questions. Cool. Thank you very much.
I'll just go ahead and start. I'm sure people. All right. Hello, everyone. Welcome to my talk, GNOME and Sustainability, Ecosystem Management. So a lot of this is about ecosystems, but first I want to talk a little bit about myself. I actually worked in ecosystem management for the last 6 years, and my last role was a principal ecosystems engineer. And what I did was, you would throw me into an ecosystem like I don't know, open firmware or something like that, and I liaison with the community and nudge the community moving forward. So I spent a lot of this, but the reason I can actually do that is because the skills I learned working with the GNOME community. So there is a way to get from working on a community project and actually making good money doing unique roles. And the GNOME community and the community it interfaces with the enthusiastic desktop users and things like that gave me some incredible skills to work through conflict and various other things. So I want to thank GNOME for giving me these skills. So with that said, let's talk about ecosystems. You know, ecosystems is such a funny word because as you heard today, we're talking about ecosystems all the time. And I don't remember 5 years ago or 6 years ago talking about the term ecosystems. And when most of the time when people think ecosystems, they think it's ecology kind of thing where it's the Brazilian rainforest or deserts or things like that. So to apply it to software, I think is kind of new. And it does make sense. In fact, we did create our own ecosystem called the Linux Apps Ecosystem, which we started back in 2017. But to me, to redefine ecosystems is really communities working together, right? We're talking about meta communities because in an ecosystem, at least from an ecology point of view, you have organisms working together within, let's say, a rainforest, a desert, things like that. But in software, it's really projects working together and through a singular kind of purpose. So what? I mean, why is ecosystems important? And as somebody who's really cares deeply about free software, about the GNOME desktop, I want us to grow. I want us to spread. I want us to grow our mission. I want us to move forward, and I feel strongly that in order to do that, we need to grow and feed our ecosystems, right? And with that, that means growing our ecosystems, talking with other ecosystems, and so forth. But the best part of that is when you do those things, you're actually building influence and relationships with other projects and so on. So further on in the slides, you're going to see what is the impact of actually building an ecosystem and what success looks like. So I talked about investments in ecosystems builds influence. What does that mean? So if you build influence, you actually have a seat at the table. In fact, we talk about this all the time with users who demand things of us, who wants us to implement features, who wants us to fix bugs, and various other things. And the common refrain in almost all open source projects is, well, you scratch our back and we'll scratch yours. I mean, our priority comes to the people who invest in our ecosystems. And that's the important part. If we're not investing in our ecosystems, why should they prioritize anything we do? versus anything else. And that's going to be important, especially if you think about design, right? If you want to convince other projects to say, well, this is a better design, if we don't want this other thing. But if every other projects that Windows or Apples are using it, then, it's still going to be floating around. But if you're invested in those things, you can build pressure and change things. The other thing that's important here is insularity, right? Diversity, equity, and inclusion, we talk about that a lot, right? We talk about all of that as part of a human community kind of thing, but it applies to organizations as well. If we are insular, then we're also static. That means we're not really growing, we're not moving, because we're just sort of sitting in our own space and not doing anything, right? And how do you get new ideas? How do you do anything if there's not a series of people going in and out and providing that kind of feedback? So we want to avoid isolation. We want to make sure that we are part of a vibrant ecosystem or series of ecosystems. This is a troll title. And sometimes when I'm talking about isolation and things, maybe we should think about, are we isolated? Are we insular? And, I want to say of something positive. This is an amazing community. Every time I come here to GUADEC or even online, I always feel like I'm amongst friends and family, and it's just a wonderful thing. And what makes me excited about I've been in this project for 23 years. All right, not many could claim that, other than some of the other folks here like Federico and so forth. I've been here this long. What makes me keep coming back is because we do some of the most amazing engineering work. I love going to other projects and talking about the work we do. But a lot of times we're misunderstood, and that's because we stay in our own lane. And we're not out there discussing and talking and various other things, right? It frustrates me because I go amongst all these ecosystems, because, as I was telling you earlier, my job is to be with moving around different ecosystems. So I'm always hearing and listening to things that I'm thinking, we solved that. We solved that. And so it drives me crazy. So I just to put it into context, I want to bring two examples that did frustrate me, that did kind of feel like we've solved this problem. So one of the things is, I was on FOSS backstage. I think it was 2020 or 2021. I think it was, and they had a whole track of designers, and they're talking about solving all these problems. And GNOME has included designers as part of its development process in 2011, or even beyond that. And we are leaders in integrating design into the free software development cycle. And when I see, like, it took them this long to start talking about, oh, yeah, we should figure out how to do design in open source. Like, we already know how to do that, right? And so I'm sitting here, and this thing was like banging my head against the wall going, we solved this. And then these back channel comes like, we should have our designers show up. We should have KDE designers show up. So, from an app ecosystem, like, we have interfacing to do. And so that was one of the things that frustrated me. Like, presence is important. And if we are solving problems that the open source community is only now being aware of, we should be out there saying, we know how to do this. We know how to build this thing. Talk to us. Let's show you. We've already hit every roadblock. How to do all those things. Talk to us. The second one is tool chains. And a lot of times people use tool chains. They have no idea where it came from, right? And one of my favorite is Meson. And I was doing some work in the open firmware community. There's a project called OpenBMC, which is one of my favorite communities because I can always get something accomplished. When I jump into their chat and ask a question, within 3 seconds, I get my questions answered. And it's great. But then one day I looked at I had to build OpenBMC for my job. And I'm like, holy crap, they're using Meson. And this is like a corporate kind of thing. It's like, wow, this is great. And then I reached out to them and they're like, yeah, it's great, but I don't know. We have these problems. I'm like, well, did you talk to the Meson developers? No, who are they? And so I'm like, all right. So I had to liaison with the Meson folks. Like, hey, these guys are doing this and this and this. Like, this is a big deal. And so, again, it's a point of frustrating. It frustrates me that people don't know. And it's important that they do know because going back to the first part about jobs, right? GNOME branding is important because people should understand the accomplishments that we have and its members, right? And things like systemd, all those things came from because we were solving desktop problems. And yet now it runs on almost every Linux computer. So ecosystems, things like, how do I know that this is the right thing to do? How do I know? How do I know? Well, 6 years ago, I talked to the GNOME Foundation saying, hey, I want to do this conference. And me and a bunch of other people. And we wanted to build an app ecosystem because I believe that we can, as an organizing principle, even though there's so many different kinds of projects focusing on various things, we can all agree that apps are important. That we can build an ecosystem around apps. Apps is important because it doesn't matter what our philosophy is underneath for all these projects. So we did. And we built a collaboration model with 3 projects. And that's KDE, GNOME, and Elementary. And a lot of them showed up. And it's sort of funny because I have this really bad habit. I take something and then I blow it up. So the original predecessor to the Linux App Summit was called West Coast Summit, which started off because somebody dared me to build something on the West Coast because I complained that we didn't have anything on the West Coast because we had Boston Summit. For those who don't know the history, Boston Summit was a mini GUADEC back in the day. So anyway, we did that, and then after 5 years of building this ecosystem, working with partners, we had some really good positive results. So this is from the blog from Canonical, all right? Its humble origins aside, LAS has immense potential, and with solid cooperation between KDE and GNOME, it could become the de facto face of the open source community. It is indispensable for Canonical to be part of that journey, all right? That is one distro, the most popular distro, saying building this app ecosystem is strategically important. And the next one is from KDE. Meta topics aside, there's also one of the core topics of LAS, collaboration with our colleagues from GNOME, which unsurprisingly, everyone at LAS was very open and interested in. I had interesting conversations about working together on maps, data infrastructure, access to public transport data, and energy efficiency eco-certification, for example. So now we have somebody on the KDE side saying, this is a wonderful thing. Then from GNOME side is Sam Thursfield. I personally met more folks from KDE than I have ever have, and felt like a lot of important desktop-related knowledge and sharing took place. that is what happens when we create an ecosystem that we feed and care. People actually get it because we've tried before, but we didn't do the right subject. We didn't pick the right ecosystem building apps. And if you attend the AGM, you can see a lot of that processing happening. That this is important, and feeding is a thing. So this talk is really an augmentation of the AGM. Is what I think is what I really enjoyed about the AGM was we're all aligned, at least from the foundation and from what I'm thinking, and many other people in this community. But as they said in the foundation, we cannot stop there, right? And we need to partner up. We need to partner up as many partners as we can. And I've done a couple things like Microsoft, Electron, React.js. These are all application toolkits or ecosystems that we should be partnering with. And because we have to think that we have something of value for them. But the only way they would care about us is if we had presence. And I think one thing I didn't consider before while I wrote these slides is from the AGM is how can people do that, right? Because people have their own lives. If they have children, they're parenting, they don't have the right infrastructure around them and so forth. So that's something to consider, but we can do that if we continue to grow the community inside GNOME or KDE, because other people will take up the slack. We are more powerful together than a bunch of projects working in their own silos, right? So that's something I think is a point. And I keep hitting this influential thing because it is so key. The influential part is so key because let me give you a brief aside. So my partner has this thing she likes to talk about. It's called manifestation, and I like all of us to manifest what that end stage looks like. If we are influential, we have the power to get hardware supporting us, right? So if people if we're at the top tier, that means we can dictate. Hardware manufacturers would want to support us. That means we're actually driving support to the Linux kernel. It's because if we succeed, other communities that are next to us also succeed. So this is an important part, is we're all interconnected. And so this influential part is important because once you have that, our priorities are taken into consideration. So I'm going to say something in practice, right? Because I'm not just talking out of my hat. So Electron recently had support for GTK's file portal, and there was a PR made. A lot of work was done, but that PR was sitting there languishing because, okay, who's GNOME and why should we care, right? Because a Linux platform is not something they care about. So this is an example. So we got into the Electron community. Somebody asked me, "Can you help?" Right? Because sometimes people ask me to help them with external ecosystems. Again, this is why I get paid to do this stuff, because people ask me to do this, and I learned how to do that. And I found my way into this Slack server of backend Electron kind of thing. And then I had a meeting with them. I talked with them and say, hey, we have things to talk about. And we worked out a relationship. After that, when this thing came in, I go, hey, can somebody help? Within a day or so, somebody looked at the thing and it moved a little further. And a couple of months go by and again, it's sort of languishing. And then again, I go, hey, it went a little further. And within a year, we actually got that PR accepted. So I don't know if the current Electron supports it or not, but um, it took that long. But this is an example of how investing in other ecosystems is there. One of the things I envisioned was actually giving talks at Electron conferences, because that presence is there. Like, hey, the Linux platform is important. Here we are. We show up, and because we're there, we have a presence. We're investing. I mean, even if the GNOME Foundation was a sponsor, that alerts the community that we think Electron is important. And so that's how we can, things that we care about, because Electron apps are our thing, right? People are using them all the time. Zoom being one of the big ones. And because we fixed that, things like Zoom or whatever else is starting to work for people when it didn't have before. Oops. How did I? Wow, I went through the end. So we know it's important for new voices and fluence. And this is, again, one of those things that I really appreciate of where the foundation is going, is allowing non-foundational members to be part of the foundation board, because they have a lot, other ecosystems have a lot to teach us. And if you're insular, it's not just that they can teach us, they have contacts as well. And a lot of this is we want to build funding. And if we're not having presence, it's hard to say, well, why should we invest in you? But if you diversified your foundation board, you diversified how we work with other, then we have an opportunity to do great things. So I'm sure all of you are supremely interested. How do I get involved, Sri? How do I do this? How do we do this? So this is my call to action. So let's work on, let's organize it. Let's work on doing the outreach. And if you are a designer, for heaven's sakes, go to some place like FOSS Backstage. Show up. Talk about it. And I think your work is important. Other people will think, because they'll hear your passion about that. And you will attract other designers. And maybe they'll be interested in coming here and helping design apps, not just on GNOME, but if you're building third-party apps, we don't have design resources to help them make good GNOME apps. We don't scale. We don't, the number of designers we have, we don't scale for that. So the more we have, we can actually build a whole community of designers and encourage a community of designers to do that. Or if you're a GNOME software developer, do talks at other conferences. There's conferences like Linux Plumbers. There's the Linux Foundation conferences. There's a nice small one. Neil mentioned Seagull. That's a great open source free software related conference. There's a lot of great places, and some of them are really strategic, right? So my favorite is Linux Plumbers Conference. For the past 2 years, I've helped organize a micro conference. I didn't do it this year because I was lame and I had other things going on. But we did. We had a number of KDE GNOME people, and we had good attention. But the best part here is, for the longest time, the kernel developers and the app ecosystem developers have drifted apart. And we really need to bring that back around, because that is we enjoyed such a close relationship back when, and we need to have that back. So I think that's an important thing, is to be able to that these conferences are strategic, and the same thing. And don't be afraid to think even big. Like, one of the things I wanted to do was go to Microsoft and do a talk there. And now you think, why would Microsoft be interested in a talk from a GNOME person? Because they know desktops. They've been building desktops since the 80s. But no, they would feel our pain in the engineering. They would be interested how the engineering came from, where we started from, and where we ended at in the past 25 years is a journey worth talking about, because they have probably had their own grades of pain. They probably had the same kind of problems, especially when it comes with UX, with various other things. But we're doing it all in the open for them to analyze and learn and grow from. So that is a great part of that. And that's where we do our value. The same thing with Apple or anything else. I think this is one of the things is where that presence comes in. We should think as high as we can, as far as we can go. Again, manifestation. And finally, if you're not comfortable going out there, there's still the app ecosystem. You know, as you saw in those quotes, people are comfortable working together because it's really a lot of them, KDE, GNOME, Elementary, they're all sort of the same kind of people, all working and being passionate about a desktop. And it's a comfortable place to be. 10 minutes left. Okay. I should have gone slower. But it's not just coding people or people who are who do primarily do coding or things like that. Translators, community management, all of that. You know, the number of PRs or merge requests I've done in GNOME is probably still maybe in one hand, right? But I provide value to this community and a powerful voice. Same thing with translator. Tibald Martin came from translators, and look where he is today. He is moving things. He's a mover and shaker. He's an amazing individual. I love him so much. But all of them build incredible skill sets that we need and want. So it's not just technical people is the thing. Sometimes the gold is in these places, and so if they went out and did things, I mean, that's how I started. I started arguing with people. I turned that into a job. So so that's and those things transfer everywhere as I've found. So that's another thing. So I want to wrap this up. All right. Ecosystem investment can be a huge payoff. And you just saw, go back to that canonical quote. They could be the face of open source, right? I know where I wanted to go. I manifest that. I think there's so much more growth and potential in building these ecosystems. But one of the great benefits of those things is the trust between GNOME, KDE, Elementary. Anybody who's participated in that ecosystem has built trust. We can get things done without a fear of running afoul of design of philosophies, of project philosophies that they may have. And I think that's one of the great lessons of Linux App Summit and app ecosystem is that ability to be able to get things done and move forward without overly running into issues. So I think we are amazing as an app ecosystem. I think you're amazing. Let's show the rest of the world, huh? So you want to talk more about app ecosystem? Sorry. I don't know. Okay. Hit me up. I have other. I think every one of the times I do these talks, I have another new initiative. The last time was Accessions Rebooted, which is moving quite swimmingly. But I also, one of the things I want to support this ecosystem and is the ability to do metrics. And so if we can quantify the work we're doing or qualify, we're able to actually show those other ecosystems our value by actual numbers, right? People take numbers very seriously. So if you're showing some quantitative analysis of the work we do, then that makes people sit up and notice. You know, I go to a lot of these conferences like Sustain OSS and things like that. They're throwing numbers, banning it about. We as a community don't measure it, and I think if we do, we can actually solidify our messaging to other ecosystems and make them better and make them take notice. So if you're interested in being a fledgling data scientist or everything else, we can always use those things too in this community, so we can add more of that. So anyway, that's it for me. And that's all. Looks like we have time for questions. Do we have questions? All right, go ahead. Yeah, that'd be great. I have hearing issues now because I'm old, right? So I can't hear as well. To encourage using our tool chain, porting. Yeah, so like Misan is a great first thing to convert, right? Because a lot of people are using all kinds of stuff. So if there's anything like using AutoConf or whatever, get rid of that hot mess and port it to Misan and talk about it. Hey, Misan came from here. This is great. And so those are great intros for tool chains. Let's see, what else would be interesting? And Misan is like the most neutral, but everything else, you know, people use different things. But I would start with Misan. I think that would be the best in terms of messaging. Uh, do you, Robin?
So you mentioned, how do we get more people involved from, different types of backgrounds, design, translators, community organizers. What do you think some strategies are to bring people into the community that might be really excited about sort of like the sort of like ideology and ideas behind the project that we're doing, but are accustomed to different tech stacks and, are most comfortable working them? How can we come together and still, take advantage of these really enthusiastic people, great talent pools and ideas, while still, not making them jump through unnecessary hoops to
Right,
to
you're
collaborate?
talking about the onboarding experience in there. So I have a lot of ideas in this space, and one of the things I did maybe last year, especially a lot of folks from Africa, was do something called scalable onboarding, because the problem with onboarding today is it's hard for when maintainers are already super busy, at least from the technical ones, but there's no like emotional space to onboard people. So to really make that, and the same thing with the interns, like they never see each other, so they're not also building relationships. So one of the things I wanted to do was actually do onboarding videos. So if you build enough videos, and I think you said something about theater or
Theater?
theater. Did you talk about was like other kinds of contributors? Like this is where somebody with like a theater.
Other types of contributors from other backgrounds, translators, community builders,
Okay,
designers.
community builders,
Theater
But
could work too.
actually,
Yeah,
I would
yeah.
love theater people. I think
Yeah, no,
because they
totally.
build stories, right?
sure.
So
Yeah,
stories
storytellers.
is important.
Storytellers.
There's room for so many of those, but onboarding videos that help build, give you context of who you're contributing to, right? So we had this long history. We should be able to put that in a 3-minute slide and be able to get them enthusiastic. But then also the onboarding videos and documentation is really a great place to put money and time into. And I think that will help by taking the pressure off the maintainers or community members or whatnot. So sometimes it's hard to be hand holding all the time.
Cool. Thanks.
Any other questions?
Looks like no. So in that case, thank you very much, Sri.
Thank you.
That is very fancy. Also, should I take a step back? Or yeah, you're going to do camera stuff, I guess. Okay, so I don't have to think about where I am. That's good. But the thing is, I don't know what people are saying in the chat. So if someone's saying that I should start, I can't hear or know about it. Or, yeah. Step to the left, maybe. Step to the left? My left?
You can
left?
start wherever you want. So go on.
Okay. Like, can you confirm with the people organizing whether this is fine? I can start. Okay. So, hello everyone. I'm Tobias. I'm on the design team. I work for Purism, where I'm on the Purism design team, and as part of that, I work on kind of like every part of GNOME as part of the broader initiative to bring things to mobile, to make them adaptive. And yeah, I've been doing that for a number of years. And probably, like, I don't know if you've seen my previous talks or know some of my other work, you probably know me as the guy who like talks about fancy widgets or animations, things like that. But if you know me a little bit better, you know that I also do a different kind of activism other than like free software. And that sometimes looks a little bit like this. So this was an Extinction Rebellion action here in Berlin early this year, where basically it was the week that the new IPCC report had just come out, that basically said that the 1.5 degree goal that all our governments agreed like 5 years ago was going to be the thing we shoot for like over the next few decades and so on. Yeah, that's fucked. That's not like basically impossible. And so yeah, we had this action in central Berlin on this bridge where you get to the government buildings with this street blockade. We had this like 1.5 degree symbol there basically, and we were chained to it or like inside it, and like basically made it such that the government has to basically destroy the 1.5 degree goal in order to like clear the road. So kind of like this symbolic action. But before I get too deep into this, I do want to like maybe issue a quick trigger warning. Like this is going to get fairly depressing, and if you're not in a situation where it's good for you to hear that, yeah, be advised. But yeah, continuing that thought, I have done over the last, I don't know, like 3 years or so, a fair amount of climate activism, mostly here in Berlin and like in the local Extinction Rebellion group and various things around that. For example, like the last few weeks we had Aufstand, it's called Aufstand der letzten Generation in German. It's like the last generation basically that can do something about the climate crisis. Actions here like blocking highways. This is me briefly before gluing my hand to the road to like make it harder to clear, right? Because otherwise, like once the police shows up, they like immediately drag you away. But if you're glued, it takes a little bit longer. And yeah, it is sometimes some fairly intense stuff. And you do expose yourselves to risks of various kinds. And I think, yeah, sometimes people who are not as into this topics like have a hard time like understanding like sort of the motivations for it. So like maybe I can give a little bit of background for that. Although I'm sure for most of you that isn't particularly needed, but yeah, quick refresher, I guess. Yeah, we're in the middle of a climate and ecological crisis. This is no longer the thing that, like, you know, when we were kids, they were telling us, oh yeah, this is going to happen to our children's children. And in the future, it's going to be real bad. And like a lot of polar bears are going to die. This is like, you know, all of us are living through the real world effects of this all the time now. To varying degrees, of course, right? Like in some countries, it's already much worse than in others. And of course, being in the global north, you're somewhat shielded from it. But even here, right? Like, I mean, this week, people coming to this conference were delayed by exactly this kind of stuff, and you're really, I don't know, like seeing an accelerated pace of every kind of disaster imaginable. Whether that's, yeah, I mean, right now in Italy, where I'm from, like they're rationing water in large parts of northern Italy. They're like, from what I understand, like they're not planting next season's crops, which is some really scary stuff, like thinking a few months or years down the line where like you don't have enough water until you like take these drastic measures that then, yeah, are gonna have like second and third order effects. And the scary, and I mean, I could name a billion examples, but like really the scary thing about all of this is that so much of it is basically locked in, that like we know that even if tomorrow we stop emitting completely, we know that like for a few decades, things are gonna get worse, or like we're gonna see horrible effects from it for several decades. And yeah, just like sort of in terms of the horror that we already know is going to come, right? We have like just drastically huge areas of the planet are going to be drastically harder to live in, to the point where like half the year, the combination of like temperature and humidity is such that you cannot be outside without, or you cannot be outside, like, right, the human body cannot exist in those conditions. We're going to see famines, not just in the global south, where, yeah, like in Madagascar, we've had climate-induced famines for several years, but like, or I think like all of Eastern Africa, but like, we're going to see them in the global north, right? In a way that we cannot imagine now. We've seen like some very small things in this direction with COVID, right? Like where certain goods were not available for certain times, but like this is coming for all of us in our lifetimes. We're going to see more of the kinds of wars for resources that we're seeing at the moment, and I think especially as things like water are going to become scarce in various areas, such as here in Brandenburg, where like yeah, I mean, and really all of Germany, we've had a drought for several years. This stuff is really going to start to come to a head in like the next decade or two. And of course, what we've also seen this week, for example, is like a lot of our infrastructure is not really built for this kind of stress. Like the example was like the rails in the UK are not really built for the kinds of temperatures that are happening like this week there, and as a result, like trains are not going. And all of these increasing stresses like are paired with the system's inability to like cope with them, because it's more and more. And of course, as a result of all of those things, we're going to have like numbers of people having to leave where they live on a scale that we've never seen. Like the conservative estimates are like hundreds of millions, but a lot of estimates are billions. That of course you never know, but like just for comparison, we had like 5 million people leaving Syria for like when the Syrian civil war happened. I don't know what kinds of like second and third order political consequences we're going to see from like 100 million or a billion. And these are kind of like the things that we're going to have to live with no matter what. But the scary thing about the climate system is that there's also these non-linear things, right? Like it doesn't just get worse in the linear fashion. Like there's tipping points and feedback loops in various parts of the Earth system that once you hit them, they're kind of like a self-sustaining process that you can't really stop, because at that point, like for example, like in the permafrost in Russia and other countries contains so much methane that like once the melting there really gets going, like that emits a lot more greenhouse gases than anything we do, and there's not really like any way to stop that. And so there is a certain point, like people don't know if it's like going to be like around 2 degrees or like maybe a little bit past 2 degrees, like, but there's a point somewhere where some of these processes just like cause uncontrollable heating that is like outside of our control. And yeah, that's really scary shit. And what science is telling us is that we basically have around 3 years to turn things around. Of course, no one knows like exact numbers. It's all probabilities, and like 67% to reach like 1.5 degrees and all of this stuff. But like at the end of the day, like, yeah, if you like actually think through those implications, it's incredibly scary. And yeah, the question then is, right, like if in the next 3 years we have to get to the point where emissions peak and then go continuously down like every year, that level of change, like what needs to happen, right? Like what are we gonna do in those 3 years? And I think yeah, at this point, it's relatively, I think, well known, or I think it's relatively common in the discourse that, yeah, we're not going to solve this by like buying bamboo toothbrushes or whatever, like changing some small consumer behaviors on an individual level, because the really big things, right, are not dependent on those choices. Of course, there are certain luxury emissions, like, yeah, if you have a private jet, yeah, don't do that. But like, if I think often, like, really, people talk about this so much, when really you could be like, okay, cut like a few things that like are really high impact out of your like consumption, and then spend the rest of that energy working on actual structural solutions. And I mean, yeah, here's two random examples. Like beef has like much higher emissions than any other meat. And like, if you just like switch from that to some other meat, much bigger difference than like, yeah, all kinds of other smaller choices. Or yeah, air travel is like, I think, very famously, just like way worse than any other kind of travel. But really, all the solutions that actually like move the needle for like the stuff we need to do, which is like emissions peak in the next 3 years, are structural solutions, right? Like, we're not going to get people to switch away from cars if there's no public transport where they live, or like a billion other examples of that sort. Of course, the problem is that what we've seen over the last 40, 50 years, that we've known this stuff, right? Because we've had these conferences since like the 80s. All of our leaders have known this the entire time. And yet we've emitted more and more every year during that period. I think like we've emitted more since like the first COP than the rest of humanity, or something like that. Like, there's some really insane numbers if you if you actually look at them. And it just goes to show that like the current political system and the economic system that it like is interwoven with just is incapable of changing anything. And of course, those, yeah, that is kind of like always the hardest thing to attack, because you're really talking about a change to that entire system. And the only like comprehensive strategy for doing that I've seen is what a bunch of like civil disobedience groups are trying all over the world, which is basically like mass mobilization. Like, you mobilize a few percent of the population to do mass civil disobedience. You do enough economic damage that the government can't just like ignore you. And then you like institute an actually democratic process for choosing how we're going to confront this crisis. Obviously, like, this is the super short summary. Like, I could give a whole talk about this or like many other aspects of this, but just like to put this in context, that is the strategy that like Extinction Rebellion and various other groups, like if you're in the UK, you maybe know Just Stop Oil, or I think in Canada there's like Save Old Growth, and Australia has a few, and like in all kinds of countries there are groups doing this strategy in various ways. Like, there's different like mobilization and tactical like considerations, but that is basically what people are trying. And yeah, this is what that looks like in the ideal case. Like, this was 2019 in Berlin, where, yeah, if you like have a large enough number of people doing relatively low level civil disobedience, you can really like change things. And what we've seen before COVID, which kind of like made this whole mass mobilization thing like a little bit harder, or at least changed it, is that you can get real things done with it. For example, like in 2019, that is one of the main reasons why the government declared the climate emergency in the UK. And so there is the question, right? Like, we have 3 years, like there's this massive problem that's basically going to like upend all of our lives if we don't solve it. Like, you know, it really puts everything else into perspective. Like, should we just be working on this instead of, I don't know, yeah, like fancier buttons? And I mean, obviously, yeah, I mean, from the context here, I think you can guess that my personal answer is yes. Like, I mean, this is the main thing that all of us should be thinking and working on. But, and that's, I guess, the second part of this talk, I think free software, regardless of that, is a really important resource in the future to come. And yeah, that's what we're going to get to later. But I think, like, especially if you come like I do, I mean, like from a privileged like background in the global north, like as a white person, like who generally like all of the systems that that are extracting resources and like people's labor in the world are basically built to protect. Like, it is really hard to imagine yourself as like opposing that system actively, right? It's, at least for me, I don't know. It's really scary to think of like being actively in adverse contact with the police. But at least what I've found for myself is that, especially like given the insane crisis that we're facing, it is actually relatively bearable, especially, I mean, obviously in the context of a country like Germany, where like there are like relatively liberal laws around things like assemblies, and police is not just going to shoot you, which there are very definitely countries where that does happen, right? But like in this context, the amount of repression you're going to get for this kind of civil disobedience is relatively tame compared to the stuff that we're facing. And so, yeah, on a personal level, I think I've had a real change of heart in that over the last few years. But yeah, like just to continue that story from before, how an action like generally sort of works out is like you have a few people who are like locked or glued or something to like make a blockade really hard to clear. In this case, I was like glued to the sculpture. Like my hand was like in this metal tube, and then the wooden structures around it. So like you basically have to go in to actually get to the lock and so on. And then what happens, like eventually the police, I mean, unless you like literally have enough people that the police can't clear you, which we're unfortunately not at that level yet. Eventually the police does like slowly clear everyone, dismantle the structures. And in cases like this, yeah, they have to actually like dismantle the blockade. And I guess we did symbolically like get that that idea across, that like the police literally had to destroy the 1.5 degree target in order to clear us. And then yeah, I mean the locks are so like dismantle. Like in this case, they had to like cut the metal tube so they can get at the thing from the inside. And then depending on the case, I mean right now like it's not happening very much, but like in this case, they did take us to jail for a few hours. And then I think we were out at like 10, 11 at night. And generally, like yeah, when you come out of jail, like there's a little like party in front of the jail. Like it's definitely a subculture of its own. Like it's a really interesting community, I think also. But yeah, that's just all of which is to say, like a little ad here for civil disobedience. There's not really many things we can do to like actively have hope. And for me, like this is by far the most realistic one. Obviously, the situation overall is incredibly grim, but like just reading the news and being depressed, yeah, I don't know. that I think is in a lot of ways a much less empowering way to cope with this than at least trying to use the little time that we have, because it is very little, to maybe move the needle a little bit. That sort of concludes the very rushed like first part of this talk, because this is like all mostly context to what's coming later. But like, I do want to pause here for a minute, because I think like even as someone who's done like a fair amount of activism for the last few years, it is really hard to let the just practical realness of this crisis emotionally affect you. Because like in daily life, we're like so good at like not thinking about, I mean, a lot of other problems too, but like this in particular, right? Like mapping the things that physics is basically telling us is going to happen if we don't change course, mapping those to like our own life's trajectory, right? Like, I mean, if we're talking about like 15, 20, 25 years, like where am I going to be? Like what age am I going to be? Like, I don't know, I guess in my 40s or something? Like what is it going to mean like for friends, family, like loved ones? And that is like, I don't know, I think a really strange part of this crisis. So I would maybe like to have a minute of silence to just try and emotionally connect to that. I know it's hard, but maybe we can try. Okay, thank you. I don't know if that was a minute, but maybe it was roundabout. And with that, we can move to the second, unfortunately not more uplifting part of this talk, but I think it offers maybe a different kind of hope. And I think that is actually concretely thinking about what it would mean in material terms, what it would mean if we don't succeed, if in the next 3 years nothing happens, we continue emitting the same like as we have before or more, and then maybe we continue doing that for, I don't know, another 10 years until basically the system runs into a wall. And I think especially in the context of this conference, what would that mean very concretely for the kind of work we do? What would it mean for the libraries we release, for the apps we design? And I think putting that in context, at least for me, has been a really helpful like exercise to, I don't know, like be able to actually like think of this as a real thing rather than like an abstract warning. And so as it turns out, other people have had this idea, and there's a discipline called collapsology. Interestingly, a lot of French people are into this, and like they're researching basically like the causes and sort of scenarios of collapse that we're likely to face. And this book is one of the main sources for the following section. In case you're wondering, I can recommend it. It's very interesting and not hard to read. And so I'm gonna try to like using that paint a very vague but maybe somewhat more realistic picture of the kind of future that we might face in case of failure. Very concretely applied onto the stuff that we do. And so I picked a few specific things here rather than just like in general, like all the kinds of different things that could collapse, but like just specifically the things that affect computers. And so those are supply chains, the power grid, the internet, and corporate structures, just like companies. But of course, there's a lot of other stuff that is maybe going to be more important, like food. But in short, like the things that are really at risk are complex, centralized, and like interdependent systems. If you have like a lot of different complex things, depending on each other in a specific order, like that is where disruption like can most easily sort of get the whole thing to collapse. So going through them like briefly, supply chains I think is an obvious one in the context of the last few years, right? I mean, obviously the picture here is that ship blocking the Suez Canal, but we also had a bunch of other examples, like COVID started and like all of a sudden there's no toilet paper, even though there was no shortage, just like random like environmental factor like causing shortages that then like jam up the supply chain somewhere else. What we've seen with the war in Ukraine, but I think most especially with the chip shortage, right? Where like a number of factors around the pandemic just like made it so that all of a sudden you can't buy the PlayStation. Like it's just such a weird like set of coincidences that come together like to cause this massive effect. But of course, like this is just like a small example of what we would see in the case of like really full-on climate collapse. But in terms of like the things that it would affect for like us, it's basically like all of the resource extraction machinery needed to make new computers, right? All the rare earths and metals and so on. The global shipping, transport, and trade network that's required to like ship components from one country to the other, like ship the assembled machines, ship the raw materials, do all of that just in time. Because one of the interesting things about like this whole topic is that in a lot of areas, like we've been getting worse and worse. Like all of our systems are getting less resilient over time. And so just-in-time production is a great example where like if the supply chains stop running for even just like a few hours in some cases, the whole like production needs to stop. And that's just like so much less resilient than if you have stock for components. But moving on to power grid. Obviously you need power to power computers. And as we've seen over the last few years, that is also infrastructure that is very prone to being affected by natural disasters or just like unusual like loads or various combinations of factors that make it less stable, and that can mean that there's no power in certain areas for periods of time. And that affects a lot of things in a lot of weird ways. Obviously, air conditioning is a big one if you live in an area where it's literally too warm to be without air conditioning. But then obviously that has impacts on the power supply as well. Again, if like you need to then cool the entire country like the moment you have power again, and there's possibly a world where like this is part of the reason why there's like only power half the day, because like if there is power, then like it's all used for cooling. But yeah, in the context specifically of computers, there's like a whole bunch of things that just like obviously need power. And as things become more brittle and less reliable, that's going to be a real problem. The internet, well, I mean, apart from also being a thing that needs power, but yeah, just in general, is sort of this large like single interconnected network that we have, that is also potentially subject to a number of stresses from like weird regimes coming to power, like wanting to control it or like seizing parts of the infrastructure. Yeah, like just in general, it's infrastructure that needs to be like kept running at a very local level, right? Like your local cables and cell towers need to be working, and that requires this whole system to continue running at a certain like efficiency. And obviously all kinds of stuff depends on that. Yeah, like this is another area where like a lot of like industrial machines like increasingly depend on the internet or like are remote controlled or stuff like that. And that is obviously required for production of a whole bunch of things. Yeah, in a lot of areas you need mapping and like GPS, which obviously isn't directly like the internet, but it is sort of connected to this whole area of like, connectivity and needing like really large global systems to continue running and like be serviced and so on. And yeah, of course, like as we all know, like all of the like documentation and like information resources that you need to do most of modern life, but specifically like software stuff, that requires the internet, right? And yeah, communication and any kind of like interactive thing you need as part of the process, difficult without the internet. Finally, one last category is corporate structures, and specifically big tech stuff, because that's where like really a lot of like things are very directly connected, and are very directly there's like these monopoly structures that have like so much power over over what happens on like a large percentage of computers in the world. Starting with operating system updates, like I think there was the thing at the beginning of the Russia war where it was unclear if like people in Russia were going to be able to get operating system updates, and that's an example of like a second order effect of something, right? Like that's not like whatever Russia being literally cut off from the internet, but like that is a scenario that like for various reasons, like if I don't know, like a financial collapse causes some of those corporate structures to not be around in the form that we were used to, you cannot install apps on any iPhone, right? Which is pretty scary to think about. Like there's no alternative there, like unless you know how to, I guess, unlock the bootloader or something, which I don't know if that's still a thing on iPhones. But like there's so much power is concentrated there for like very basic things like updates and app installation. But of course, any kind of cloud infrastructure, very dependent on specific companies, sometimes with like proprietary infrastructure that like all kinds of stuff is built for. But then going a step further even, a lot of things have shifted nowadays to even just like the data and the programs running in the cloud. So like if you run your company on Notion or Figma or whatever, right? Like if you don't have the internet and that company's server is available in the way it was yesterday, you literally cannot do anything. Like not only can you not get your data, you can't even make new data. And of course, the elephant in the room in terms of like free software is GitHub, right? Where like so much crucial stuff is hosted on this one platform run by this one company in one country. And I think we've already seen cases where like sanctions affect that. But obviously, yeah, like a larger scale disruption of that kind of thing is incredibly scary to think about. So yeah, to summarize all of that, like what is kind of like the worst case scenario? Yeah, like all of the supply chain stuff maybe means it's really hard to get new hardware, or maybe it's impossible to make new hardware at the levels of complexity that we have been able to. Yeah, limited power, limited connectivity. Maybe like it's something that you have internet, but like it's really slow, or you only get it in certain places. And then of course, yeah, like any kind of like cloud stuff, probably very risky. And that may sound like really hard to imagine, but then you look at the fact that like there are areas in the world where this is in some ways already the case, right? Like in the global south, we've already had much worse like direct climate impacts over the last few years, from like constant heat waves to droughts to floods to famines and so on, to the second level things like wars and sanctions that obviously go to affect all of those things in turn. And then in a lot of those areas, and I think that is something we heard fairly frequently from, for example, like Endless. Like internet is not, or especially fast internet, is not like a given in a lot of parts of the world, and neither is power, right? And sort of, like to close the whole thing off, just like the idea that you can like just easily buy a new, faster computer that we just sort of have baked in to our, I guess, ethos of doing things is not necessarily the case everywhere. And I think it is hard to imagine, but it is, I think, maybe easier to imagine this becoming a thing in the global north as well, if you think about it in that context. And obviously, like this is very different from like a global collapse of the supply chains or whatever. But like, I think that is maybe a helpful tool for thinking about it. So what does the literature think we're moving towards? Like, if all of this were to happen, like what do people think is going to be the result? Obviously, it's all very hand wavy, and like they don't like to go into like super specifics. But this is like basically the summary. Like the world is likely to be more localized, disconnected from each other, constrained in all kinds of resources, because you need to like get things at the local level, and a lot of things just aren't at that local level. So you need to like rely on stocks or like rare shipments or stuff like that. And yeah, you need to generally rely on getting things done at that local level where possible, and sort of try to make do with that. But of course, you never know, right? Like the future is impossible to predict, and maybe there's a nuclear war that makes all of this kind of like, beside the point. But like that seems to be the likely scenario based on what I've read. And I think it is important in this context to point out that, like, especially like when you're talking about collapse, and sort of like the apocalypse. And like it conjures up these Hollywood images of like being out in the wilderness with your shotgun and like hunting deer or whatever. But like, I mean, aside from the reprehensible like sort of implications of like your view of humanity, I think like it's also like a horrible strategy, because like that is, at least from what I understand, that is very unlikely to help you in any way, because individually you cannot deal with the complete collapse of society. You can maybe like be really good at mitigating a very few specific things, but at the end of the day, the only way to like sort of keep something going is as communities, is in a communitarian way. And that is the sort of solution, if for lack of a better word, that people point to. Like, you need to try and work on like small scale, local sort of community structures that do as much as possible on the local level in a circular way, and so on. And that, of course, is is very different from like how people usually think about like the end of the world or whatever. And I think like the media that has polluted our our maybe understanding of that kind of idea of collapse is maybe also like part of the problem there. And so I think part of the solution is also to talk about like real community-based solutions to that. But anyway, I'm digressing a little bit. I think in that world, if this does come to pass, which we have no idea what's going to happen in the future, but like if this does come to pass, probably computing not top of our list. Like probably like we're thinking about water, food, stuff like that, first and foremost. But I think in practice there are like, given that the material sort of like base that we're going to have in this future is going to be what we have today, right? This is not like 100 years from now. This is like in a few decades. It's like the world is largely going to look the way it looks now. And that means the same factories, a lot of the same buildings, a lot of the same people, or I mean, pretty much all the same people. And so it's illusory to think of like, oh yeah, I don't know, some like 1,000 years in the future thing where like we find computers in the sand or whatever. No, we're gonna be working with a lot of the same stuff that we have now. And so I think in that context, like computing may have some really important roles to play. And so just like to give a few examples, obviously like even if you have like a super localized community with like no internet and like barely any power, you're probably going to need to do some like, you know, information storage management, like do some calculations, do some modeling for something you're building. Obviously like have educational resources, stuff like that. There's probably not a better way to do it than with computers, given like the society we live in, given the stuff that's all around us. At the local level, like networking and communication can still be useful even if you don't have access to the entire like world. And of course, yeah, like in a very sort of like material sense, like there's a lot of industrial machinery around the world that maybe in the future when, you know, we can't make cars anymore or whatever, but like maybe we can use a lot of this machinery to make things that are actually useful in that moment. And like computers are part of how a lot of this stuff works. And so we will need some computers there. And of course, I mean, obviously I don't know anything about like how farming works, but like I'm assuming there are areas in things that are like very critical to our survival that like maybe can be made more efficient using computing. Like for example, having sensors to irrigate more efficiently, like maybe automate some tasks on that level. It's possible. But I mean, yeah, ultimately this is all of course speculation. But I think like if this were to come to pass, I think free software might have a really important role to play there, right? Because proprietary technology, you have no idea like how it works. You can't edit it. You can't do anything to it, other than like hack it in in horrible ways to like maybe sort of make it do what you want. But like I think there is a real power in the idea of having like a whole material base for computing that can be done at that local level. Obviously, there's a lot of asterisks and question marks, but I think that that is at least an interesting direction to think in. However, I think it's also important to realize or like discuss how ingrained a lot of the more pragmatic parts of current economic systems are in how we do things as well, right? Like we are building our stuff on a lot of assumptions. Like a lot of our stuff just assumes you have fast internet all the time. We generally assume that like new hardware will be forthcoming and it will be better than what we have now. And just in general, like there's no one sees anything wrong with using the resources that are available at any given moment. And I think those are some of the things that maybe we need to reconsider and like see how they fit into a potentially very different future. And so I'm just like gonna go through a few things where I have questions, and maybe people here have answers. I'd be very interested in discussing this later on or in a question or something. But yeah, like I think one big question mark for me is like package management and like the way like we increasingly like everything has a billion dependencies, that all like rely on a very specific version, and that all sort of like assume that you can just download the very specific version at that very moment. And that this all like can just like sort of move without any sort of orchestration or yeah, and any kind of like consolidation. And that seems like a very potentially risky thing for a future where maybe you don't have internet a lot of the time. Yeah, an obvious one, like using GitLab on a slow connection is almost impossible. Even on a fast connection is sometimes really, really slow. And so like relying on like sort of heavy web-based tools for like very base things may be problematic. I don't know. But we'll get to that in a little bit. Obviously, like this is another area where we've been moving further away from resilience over the last few years. Like everything's increasingly there's like streaming from the cloud. Like nowadays, like even games I hear like people are just like streaming and just like running the code in the cloud. And yeah, obviously like that does not work if you don't have the internet. But I think like following on from the point before, like there is a real question if like the internet were to go away or degrade or like become more localized, what would that mean for our community, right?
Yes, can you hear us?
They exist because like people in all kinds of countries can like there are enough sort of skilled people like sort of overall to push this forward. And maybe it's possible that like there could be multiple local things pushing that forward, but like that does seem like a scary or like difficult proposition. And yeah, I don't know. I don't have an answer there, but there's a question I have. But so in a very practical way, I'd like to go through a few things that I think are directions for interesting things to consider and maybe work towards in the context of all the stuff that we've just talked about. So like a few general principles. The first one I'm not going to talk too much about because Rob already covered it in much more detail yesterday. But the idea is that like instead of assuming that you have the internet all the time and it's very fast, you assume like everything works locally first, and then if there is the internet, then we can do some nice things on top of that. So like everything should always be as fast and nice as though you were doing it locally, and then sync is sort of like an additional layer, or for example like also collaboration. But yeah, I'm not going to go into that because watch Rob's talk on the topic. But yeah, then in general, like not just assuming that we can flush the cache and like re-download everything, which we do, I think, quite a bit. Maybe find, I mean, I know it's just really hard, right? Cache validation and all that, but like maybe find more and better ways to do caching. And one very specific thing that I've worked on a little bit in the past is USB app installs and updates. But yeah, so this is the example with like local first. There's like this paper that's from Twitch wrote a few years ago, and some of them are also working on this app called Muse, which like sort of puts all this into practice in the context of like a app on iPad and like various other platforms where you can like draw and like have multimedia stuff. And it's I think it's a very fancy and like sort of I guess sort of like best case scenario example of like the kind of thing we could do there. And yeah, following on from what Rob said yesterday, I would personally be very interested in working on maybe a platform level or even just like some prototypes at the application level implementation that tries to do some of this. The other example is like USB sort of like local app installation and OS updates. I did some designs for this in collaboration with Endless, I don't know, a while back. And it hasn't been implemented yet, but I think it's still on the agenda. And I would be very happy and interested to push this forward. Like the idea is basically like you can plug in a USB key, copy some apps to it, and then plug it into another computer. And GNOME software, or just in general, like your system, can then just install those apps and updates. Time. Okay, I'll speed up. Yeah, then another one is resource efficiency. I think there was another great talk on this yesterday, so I don't have to talk about it too much in terms of power. But yeah, it would be really cool to like have tooling that makes this much easier. I think I'm like preaching to the choir when I'm saying like don't ship a Chromium browser with every app, like use the native toolkit. But I think more interestingly, maybe there are use cases around things like what if you like your only power comes from like a solar panel and you only have power like part of the day. Like should we maybe have facilities for like scheduling stuff? That's, I don't know, something to maybe think about. And here, like a concrete example, I looked up like energy use across programming languages. Python isn't coming up so good. But yeah, let's maybe try to speed up a little bit. Another one is data resilience. I think in our community and the computing industry at large, we've had this like decade of like trying to get away from the file system in some ways. And my feeling is maybe that is something we need to undo. We need to go back to the file system, because it's the one thing that works everywhere. Like it works across all platforms. It's fungible. Like people know how to manipulate parts of it, right? Like you don't need to like build a custom client for every single function. People know how to copy stuff. They know how to like take, I don't know, parts of a folder, stuff like that. And it is sort of introspectable for people. In a way that like if you have a database and like a custom like schema for like your specific notes app, that isn't
I need to
those
stop
things.
you. Hello? Can you hear me?
Yeah, like in an environment where
so
you don't have
sorry.
internet, you can't install an app to like open this custom like format. So yeah, for that, it would also be cool if those formats were simple and standardized, although I know that that's hard. And it would also be cool if there were like human readable text fallbacks, such as, for example, there's a thing called text bundle, which is basically like markdown in a zip file plus all the resources. So you can have like a single file and you can easily manage it. You don't like have a folder of stuff. And if that were more widely supported, I think that could be a cool alternative to like, so for example, Word documents in some cases. Another one is keeping old hardware running. Obviously, yeah, if you use fewer resources, that helps. But just in general, yeah, like try to support as many form factors as possible. And I know this is like slightly different from our community's focus, but yeah, like try and get it running on more hardware where possible. One example of that is post-market OS, but yeah, anyway, blah, blah, blah. And yeah, one last thing, building for repair. I think it's very hard to like get something. Do we really need to cross? Okay, yeah, build for repair. One example is a builder in that endless example from a few years ago. But there is the question of like efficiency versus repairability, which I think sometimes is a little bit tricky. But generally, I'd like to hear from you all what other things there are, because these are just some things that I thought of. And these are some people to learn from that I'm not going to go into. And these are some places where you maybe could get money to do some of this work, question mark, but worth trying. And yeah, see you in action. There's XR actions if you're in Germany or Berlin in September, or otherwise really anywhere near you in the world. Thanks. I guess we don't have time for questions. Yeah, right. Okay. In case we can do it.
thank you everyone for following. Tobias's talk was really interesting, but we didn't have more time for the questions. So I'm really sorry that we have to skip them. Maybe he can just enter the room and try to respond to your questions well in the big blue button room. So now we are going to follow Dylan McCall and Manuel Quiñones in their presentation. Go ahead.
Thanks. Okay, you'll have to forgive me. I'm very awkward, so I'm going to be juggling the microphone and this paper. So welcome to our session. This session is a bit of a project update. I think folks from Endless have been here at GUADEC a few times talking about our suite of knowledge applications, trying to bring as much of the internet as we can to people with limited connectivity. So we're going to talk kind of how that has gone, what we're working on now, and we'll dive into how GNOME gives us a really great platform to build this type of software. So my name is Dylan McCall. I live in Vancouver, Canada. I've been working at Endless since 2019. When I'm not coding, I enjoy eating food and various kinds of camping. Oh no.
Hi, and I am Manuel Quiñones. I am from Argentina, Litoral Region or Región del Litoral. And yes, I like to sail as well. We'll continue with passing the slides. Oh, yes. So, problem statement, we know that the internet, access to the internet helps makes people's lives better, and it provides access to great kind of knowledge and equity in access. And probably you have seen the talk from Rob about this subject. And also there is a great blog post from Endless founder, Matt Dalio, about this. So there is a lot of people that is unable to access and would like to access the internet, but is unable to for a variety of reasons. So how do we reach them? Our answer is storage. Storage is cheap. In a very tiny drive, you can contain most of the Wikipedia, educational content, even entertainment content as well. And we know that at Endless, we know that integration with the operating system is a big part of this. People understand apps. And what if they can search in their GNOME desktop in the same way that they Google? That's, for me, very well to consume content. So this is not the first time we talk about this, even at GUADEC. At Endless, we have been working on this for several years already. And we have the knowledge apps. These are very well integrated in the system, like I stated before. And so we have Endless OS that comes with a big amount of content already and many apps. Some are specific for different regions, and some are more generic, like Encyclopedia above. So if we have something working, why change it, right? The reason is scale. We want to make a bigger impact and reach more people. So if we want to do that, we have to scale because Endless OS, the solution I presented before, is for Endless OS or at most for Flatpak enabled systems. But if we want to reach more people, we have to go multi-platform. And also, the technology, the pipeline we had was a bit expensive to maintain. And it was in-house. It was great. It allowed us to create Flatpak applications with content very easily, but we want to go further. So it turns out that we are not the only ones caring about this, and that reminded the previous talk from Siri about ecosystem. It turns out there is the OpenSim project that maintains this file format for wiki-like hyperlinked content. And there is also Colibri. Colibri is a learning platform that is offline first. It's open source, but within the open source ones, I find it great for offline. First, it has a massive library of content already and is clearly licensed. And it runs everywhere. It's very solid. And it also supports very different kinds of setups. So there's the usual setup in a formal institution, in a server, single server, and all the students accessing Colibri from a browser, even a cell phone. But there are also different other setups, like an offline Colibri instance can distribute the content to other offline instance in a peer-to-peer fashion as well. And this is what allows us to make it work in a GNOME platform. So here is a Colibri being used in the field in Kenya. Next. And one of the selling points of moving to Colibri is the massive amount of content they have. Content is organized in channels. Channels can have different kinds of contents like video, books, and within channels, they are organized in topics. The channels are huge. There are channels that are huge, many gigabytes of content, but the good thing is that you can install part of those channels. And there's also a great pipeline for creating them, for remixing, so you can take content from already existing channels and create your own. And these are examples of content like videos or audio only with captions. There can be books in EPUB format for accessibility, readability, and or in PDF format for preserving the layout. And I think the next one is interactive content. These are HTML5 applications that there can be games even, or simulations, like physics simulations here in the path simulations channel. And also the good thing about Colibri is that it is extensible through plugins. So all of the above are, in fact, plugins. There's the video player plugin, the ebook reader plugin, and here my friend Dylan had added support for same file format for hyperlinked content through a plugin that can be easily installed.
Okay, so we've explained how Calibri gives us access to a rich library of content, and it lets us plug into an existing ecosystem of tools. So the next question is, how do we use this? The other half of Calibri is the server. So a Calibri instance stores its own copy of whatever you choose from the content library. You can access it using a web browser. It can search, and it can view all of those content types that Manuel just mentioned. The important part is it's self-contained. So Calibri also has e-learning features. So these are user accounts, and we'll actually get into that a bit later. And you can set up classes, assign learners to them, and monitor their progress. And the cool thing is this works across instances. Next slide. Oops. Yeah, wow. not that many slides.
Many?
Wow, that was a lot of slides. Okay, we're on like 19. Okay, so the key idea is wherever you're using Calibri, you're probably running your own instance. So Calibri instances connect to each other in various ways. So you can share content and other information. By using Calibri on Endless OS, we're building on top of an existing ecosystem of devices that all connect to each other. And so if you want to check them out, there's some public Calibri servers that we could link to in our slides there. Skip them. Next slide. So I've talked a bunch about how everyone should run their own web server, but nobody really wants to think about that. Fortunately, there's a friendly solution to this. So first of all, the thing to note is that Calibri is pretty complicated. I would describe it as a back-end heavy application. One of the reasons for this is it's designed to be cross-platform. It supports a lot of OSs. It even supports Python 2 for some reason. And to achieve this, one of the side effects is it has its own copy of everything, which gets a bit freaky. But it's also the reason why it's a really high impact project. And I should mention one of the nice things with collaborating around this is we're able to be a bit involved in ongoing work to make it more flexible and more straightforward for kind of a single user desktop situation. But for an end user who doesn't want to think about running a web server, what we offer is the Calibri app. And so this deals with all that web server stuff in the background. And we created the Calibri app for GNOME. This uses GTK, WebKit, GTK, PyGObject, all those usual good things. This slide has a list of features in the app, and we'll go into those in a bit of detail. The other important detail is it's a Flatpak. So this way we can support a huge number of Linux distros. It's nicely sandboxed. We get a really nice development workflow with GNOME Builder. And for Endless OS in particular, this is important because the OS uses an immutable root file system. So if we want to change anything in that requires a large point update, which we don't want to read those too frequently. So this way, it's easy for an end user to install, update, or uninstall the app just like any other app. Oh, actually, can you go back a slide? Sorry. So initially, we had something that looks sort of like this diagram. So you can see everything is in this nice little bubble inside the Flatpak. The Calibri server basically gets started up when we launch the Calibri app. We also have a search provider that deals with the database directly, just to be a bit quicker. Now you can go. Okay, but this has some issues. Next slide. There we go. Most of our problems stem from the fact that Calibri is a really big application that deals with a big problem. It takes a long time to start and stop. It's quite heavy. It involves a lot of data stored on your device. And for NSOS in particular, we found this was important because an important detail because NSOS users often share a computer. And if they're using multiple user accounts, we don't want each user account to have its own copy of the same TED-Ed video. But it still has to be a flat pack. So we have limited file system access. Everything that's dynamic goes into the user session. So we can't just stick it all in that nice little bubble per user bubble and call it a day. Okay, so what we started to do to make this work a little better was we split Calibri's server code into a separate process. It's a dbus daemon. Started off doing as a session daemon, so this is all just inside the Flatpak, and it's pretty normal. I found this was a really pleasant workflow because dbus is such a natural part of our platform that we could just separate this stuff, and it just felt like a regular bit of refactoring. And the main idea here is the Calibri daemon can start and stop after a certain amount of inactivity, independent of the application. But the really important bit here is this lets us separate it into a separate, we can run the Calibri daemon on the system bus as well. So what we did was we created an extra package that is in our OS tree. So this is the immutable part that we don't want to touch too much. So this package has to be really simple, really lightweight, because we don't want to have to keep updating it. And so this one adds some configuration that creates a system version of that same Calibri daemon dbus service. And so the nice thing with this workflow is this gives us a really nice way. Sorry. The nice thing of this approach is everyone basically runs the same code. The NSOS bit is very specific to or a very, very small bit of extra stuff. You can jump ahead.
Mm-hmm.
Okay. And I think.
Okay, so we said before that Calibri has its server side, but we want to run it not just as an application, but we also want the channels to look like applications. So we want the channels to have their own icon. You click that icon and you get different windows for different channels, and with the channel name in the title bar. So that's the integration we did for Endless, but is super thin, so it can be also for any GNOME desktop. And the reason how we did that was with exporting desktop launchers that have particular URIs that open and create those windows, but it's a single Calibri running behind. So the next one is yes. So we have integrated it also with the global search in the desktop. So you search for a keyword, and the results are organized by channels. So that's also enhances the concept of channels as apps. And how we did that with multiple search providers that call the same service. So it is very good for minimizes performance. And then the user accounts. So it turns out that if you use Colibri the normal way, let's say, you have to register and create an account, but that doesn't make sense for a desktop user because you already have a user with a username in your desktop. So what we did was integrated with the desktop user account. So there is no need to log in each time you use Colibri.
Okay, so we have our Calibri is working as a system service. All of its data is in one place, and we have a way for users to manage that content. And we also have standalone apps that are using Calibri as a backend. So that's all we really need. So now on NSOS, we can pre-install Calibri content. This lets us create custom versions of NSOS that come with preloaded content. So we can have images that are hundreds of gigabytes, and they're all useful. So, for example, we created a big OS image for an organization in Oaxaca, Mexico, that is working with indigenous communities. And you can learn all about that at Sergio's session tomorrow. The amazing thing here is really just the wealth of content that's available for Calibri. It's really easy for us or a partner that we're working with to look through Calibri Studio or the Calibri Content Library, pick out some specific content they would like to include, and also add their own when it makes sense for them. And that part of the story is already up and running. So the next question here is, what have we learned? So I can't really pretend that we didn't give a similar talk to this one at GUADEC at least once before. We've built this stuff before, and it actually worked pretty well. But our different tack here has a bit of a lesson in it. Our old knowledge apps that we built were technically very sound. They're lightweight. They still work, and we built a lot of them. But the real problem there is they're, to borrow a word from Suri's talk earlier, they're insular. So now we're kind of widening our goals and accepting some limitations that come with that. And we're putting a bit more weight on the ends rather than the means. So using Calibri is a bit of a rockier integration story. It isn't really built for GNOME desktops. But the thing to realize here is the offline content world is a pretty small one. And so there's a lot to gain by accepting that little bit of weird if it means we can fit together better and reach more people, and as a stepping stone to hopefully building something really cool together. So hang on a second, I'm trying to remember what I was going to say. Well, anyway, so the other thing that I kind of came away with here was, that's what I was going to say. Okay. Now I can sound like I'm prepared. Okay, so the other thing that I kind of came away with here is, I think this is a really good approach if you're building a backend heavy application like Calibri. This is a nice, where you kind of have a use case that is difficult to solve with fat pack portals at the moment. We think this approach, where we kind of build a flat pack that optionally integrates with a really lightweight system component is a nice way to kind of get started. In particular, this approach allows for progressive enhancement. Most of the code is the same, but we can enable features in the right conditions. It unblocked a lot of things. We've also been really happy with how some thus noticed plumbing work around the Linux desktop makes some of these problems surprisingly solvable. And it's kind of worth shining a light on how nice that is. So another project we've been working on the past couple of years is Endless Key. So this actually uses Calibri again to deliver offline content for students who are suddenly learning at home due to the COVID pandemic. And these are people who we can kind of meet halfway. They won't be using NSOS, but we can still do something for them. We can bring the experience we have with Calibri and this kind of content curation to build something that's useful. And yeah, the problem is we learned there are a lot of kids who don't have reliable access to the internet, even in the United States. So we also learned that there are even people who can have good internet can benefit from the type of curation we're doing. The internet is really challenging sometimes. So it provides a certain peace of mind when there's all this information and you can be sure that none of it is trying to trick you. And so, yeah, if you're looking for a good way to bring educational content to more people, we think Calibri is a really good place to get started. We'd be excited to talk with you about it.
Great. And what's next? So we are already collaborating with the Calibri developers, with the SIM file developers. So we want to continue working upstream. Regarding the Flatpak application, the goal is to port it to GTK4 and leave out data.
Yes.
Okay. And so the things we added for the GNOME desktop can also be useful for other platforms. So maybe the idea is to do the automatic login in other platforms as well. And different kinds of enhancement for every platform. Working on the architecture a bit more. So it now Calibri works, and now that it works, we want to make it work in a more performant way, better, faster startup. And also there are content collections. Calibri has the concept, very simple concept of collections right now. And we want to make that so that it works with external devices and bundles of content for our use case, which is self-guided learning. Calibri has broad user cases, and this is the one we are trying to improve in it. So I guess that's it. Any questions?
Hi, I think I might be the only person who's not in tech in this room. So I was struggling to, navigate my thinking between buses and daemons and flat packs and. So first, congratulations. This is lovely. And I really appreciated how you said that the end is more important than the means. And this is a global issue that you're trying to find a solution to. Can you help me understand? So when you said you can filter search by language, how many languages are supported? Do you know? A lot.
A lot, many, yes.
So not just English and Spanish, more than that.
Yes, yes.
Fantastic.
And I know because Calibri has a font that is specially crafted for different kind of languages.
Mm-hmm.
So yes, a lot. I don't have the number now,
Yeah.
but yes.
Great. And then my next question was, where is the actual content coming from and who's writing it?
Great question, because we went a bit in the surface for that. So there's the Learning Equality nonprofit that is blessing Colibri's development. We are partnering with them, and they are the creators of the public channels, which are many, but anyone can create a channel. So they have a portal that's called Colibri Studio. It is online. and the good thing is that it supports remixing as well. So if you are interested in shipping within your own channel different kinds of content from other channels, you can do that. You can remix, and otherwise you can create your channel with content as easily as drag and drop from your computer, and without any technical knowledge. So you create topics. Topics can have videos or books or interactive content or different kinds of content. And anything you want to add?
And then jumping off of that, sorry, the educator in me has lots of questions. So it's being created and developed and curated and remixed, but who is watching it to make sure it's authentic and correct and all of that stuff? So these children are getting the right knowledge.
Yes. Yes. So I think Learning Equality owns the possibility to make channels public. So they are on charge of that. The channels you create are internal, but they may pick them. And there's also the license. So the content has a very clear license in Colibri. So it's also a matter of educational curation and also licensing for distribution. We at Endless have an educator that is curating content, initially from the public from the public content, from the public channels, and yes. No, thank you. Great questions.
I guess I have a follow-up question. I was curious about some of the same things. Some of it was actually in terms of like localization, which I think your question touched on a bit. But if content is coming from a particular source that is, native or kind of written, designed in a particular language, but the platform is sort of serving in all of these, multiple languages, how is localization being handled, and is it being handled sort of at the client or server side, or is it like where in the pathway is localization happening before curation, and how is that being QA'd, for example?
Yeah, so the content channels are, those each channel is tagged with a particular language. So there's a English version of Khan Academy, there's a Spanish version, and these have different selections of content as well. You can also tie them to particular curriculums. So actually there's 2 English Khan Academy channels, come to think of it, for that reason. So that's mostly where the localization happens. And so, and it's worth noting in terms of kind of reviewing these, the vast majority of Colibri channels are not original content. They're ingested from a source like Khan Academy. And there's a lot of these out there, and it puts them all in one place and gives it all the same system.
Okay, thanks.
We also have a few questions from remote attendees. Okay, I'll just pass the microphone to Justin. Are you going to ask the questions that you would? Okay, let's go.
So first I was going to ask if you knew about digital public goods, and then I realized that Calibri is already recognized as a digital public good, so that's not a question I have anymore. First thing, though, I was going to ask, I thought it was amazing. I was just looking at the DPG registry, and you're in 186 countries that are, or countries and territories where there's applicants. So my first question is, are there lessons learned by Calibri that other apps and software in the ecosystem could learn from, like maybe top 3 tips? Or I thought that global presence was really unique, and maybe there's things that other software apps and communities could learn from there.
Okay. I guess first thing to note, the Debian package of Calibri, that's going to be just the server part. But yeah, that's amazing. That is in so many places. For us, I mean, I think one of the lessons here is just sometimes it's, if we want to build a strong ecosystem and bring in these sorts of collaborative opportunities, sometimes we need to accept some weirdness and yeah, find ways to fit them in. Yeah. I don't know, what are some good tips? Yeah. One thing Learning Equality I know are really focused on is they take a lot of time investigating who their users are, what users they want to reach, and what kinds of systems they have, and making sure they're meeting them where they are. Because if you can't just tell someone to upgrade to a system that supports Python 3 and to try out your platform. We'd like to, but it gives them a lot more. It helps them reach a lot more people when they can support this sort of history.
Thanks. And then last question, just putting on my open source community hat. I was just curious, do you have a lot of users who directly or indirectly participate in the community? And if yes, then I was just wondering, what does that look like?
We would like more. I don't know what the story is for Calibri in particular. They definitely have an active community forum. I think most of the ongoing work is Learning Equality has quite a lot of employees, so they do a really good job kind of running things themselves. They do have some summer code students this year, so you have to ask them. But yeah, for the GNOME app in particular, it's really just us at the moment. But I think there's some really good opportunities if somebody is interested in what we're doing to we can chat about it and yeah.
And for the Colibri part in particular, I think it's a great opportunity to participate in that community because they use very solid, they have a very solid architecture, the back end, the front end, they are very known technologies in both sides. So I think the barrier is low to participate.
They're also really awesome at code review, so they're great to contribute to. Yeah. Yeah.
So we have the last question, and we're right on time, so let's try to do this one as well. So one of the people remotely said, maybe I missed it, but where does the daemon service come from when the Flatpak is used on an OS other than Endless?
Okay. Good question, because I accidentally skipped over that part. So on an OS other than Endless, it still runs in your session, in the user session. The way this works is when the desktop app starts up, it checks if a system service is available for Calibri. If it is, it uses that. Otherwise, it uses the session one. And once it's sort of done that initial negotiation, that's the only bit that's really different between Calibri on Endless OS and Calibri anywhere else.
Thank you. Well, thank you, Dylan. Thank you, Manuel. This is the time we had. I think we're at the end of our first day. So yeah, a round of applause for you.
Thank you.
Thank you very much. Well, see all of you tomorrow morning with, well, not morning for everyone, but see you tomorrow with many interesting talks. Thank you for attending.
Your microphone. Thank you.